GPT-5 is on its way. Stay tuned to find out the details. Also coming up in this episode, Tesla is close to creating a full autopilot. The founder of Boston Dynamics tells what robots they'll create in their institute. NASA is giving away millions of dollars left and right to prepare for technology for the upcoming lunar missions. And chips with artificial intelligence return mobility to the paralyzed. This and other high-tech news in one place. Let's fly. The World Robot Conference, the largest robot exhibition in the world, is taking place in Beijing. My colleagues at Pro Robots are there right now to keep you updated on the newest tech. We'll be uploading news directly from the field to our Telegram channel, so make sure to check it out. Despite the claim that a neural network more powerful than GPT-4 is not trained, and that the company is focused on the additional training of the current version, OpenAI suddenly filed a patent application for GPT-5. And now there will be speech recognition and synthesis functions. That is, the new generation will get even more advanced functions for natural language processing, which promises to be a new breakthrough in the field of artificial intelligence. It also opens up all sorts of new opportunities for development of various applications. But wait, there's more! OpenAI promises that GPT-5 will include many other improvements and innovations. What exactly is stated in the application? Dated July 18th, the document describes the new downloadable computer software for the use of language models. The wording of the application remains vague, but emphasizes other functions, such as artificial reproduction of human speech and text, and natural language processing, generation, understanding, and analysis. Oddly enough, Elon Musk has yet to speak out on the matter, although we've already covered his AI strategy in detail in the issue at the link in the bottom. But the entrepreneur has news on other projects. For example, SpaceX has conducted static testing of Starship's first stage, Booster 9. All 33 engines of Raptor 2 were launched and ran for 2.8 seconds, instead of the planned 5, because 4 engines shut down on their own during this time. But the new water-based system for compensating the fire impact on the base of the launch has proved to be excellent during the test, and Booster 9 itself didn't explode, which is great. It should be noted that Musk announced about 1,000 changes in all the systems of the Starship project. In even more exciting news, Musk announced that Tesla has almost solved its full autonomous driving issues, and is now working on the last piece of the artificial intelligence puzzle. Driving is the last piece of Tesla's AI puzzle for FSD. It will reduce more than 300,000 lines of C++ control code by about 2 orders of magnitude, Musk wrote on his blog. Now the entrepreneur says that the company is being limited only by computer power. At the same time, most experts were skeptical of the entrepreneur's statement, and believe that Tesla won't be able to go from 2 to 4 or 5 level of autonomy in the near future. By the way, other experts are also betting against Musk. This, according to bookmakers, in the upcoming fight between Elon and Zuck, the probability of victory for Musk is estimated at 30% against 70% for Zuckerberg. At the same time, rumors for the upcoming fight are fueled from both sides. Musk claims that he pumps dumbbells every day in the office. The fight will be broadcast live on his social network X, and all proceeds will go to charity. Zuckerberg, for his part, says he's willing to meet at any time. What do you think? Is this a lingering joke, or are we going to see a real fight between billionaires? NASA is getting ready to conquer the universe, or at least our solar system. Lockheed Martin will build a nuclear-powered rocket for NASA and DARPA for the missions to Mars. The project is called the Demonstration Rocket for Agile Cislunar Operations, or DRACO for short. The reactor with fuel for it will be provided by VWX Technologies. The nuclear thermal engine is ideal for long-range missions because it requires less fuel and allows spacecraft to achieve greater speeds, range, and maneuverability. Such qualities can make it ideal for long-distance space missions. That said, nuclear propulsion could also be useful for shorter missions, such as delivering supplies to the moon. Demonstration of a workable technology should take place no later than 2027. According to the plan, the nuclear reactor will not be launched until the ship reaches the so-called nuclear-safe orbit. That is, if something goes wrong with the engine, the consequences should not affect our planet. The ship will get to the desired orbit on a conventional rocket. At the same time, it's necessary to solve the problem of possible radioactive leaks into the Earth's atmosphere and establish the necessary safety measures for a nuclear-powered spacecraft. Astrobotic has won NASA's Tipping Point Partnership and received $34.5 million in funding from the agency. For this money, the company's engineers must demonstrate the possibility of power transmission on the lunar surface using its LunaGrid-Lite system. This will be the first ever transmission of high voltage power across the lunar surface. During the experiment, LunaGrid-Lite will transfer power from the lunar landing module to the planet rover. How will it do this? Astrobotic will deliver a landing module with specifically designed 20-meter long vertical solar panels to the moon, as well as the Cube rover. The latter is equipped with a reel with a specially designed cable of about 1 kilometer in length, which will unwind and lay across the surface. The module will then have to transmit 1 kilowatt of energy to the rover. In the process, 3 technologies will be tested: a high voltage energy converter, a cable, and a cable laying and deployment system, all for NASA's future missions to the moon. Engineers at Carnegie Mellon University's Robotics Institute have developed a universal kit that can make any explorer out of any robotic platform. The developers claim their system cuts the time to complete a task in half and builds much more detailed maps than other existing counterparts. The Autonomous Exploration Research Team combines a 3D scanning LiDAR sensor, a front camera, and inertial measurement unit sensors with an exploration algorithm to allow the robot to determine where it is now, where it has been, and where it should go next. The system is suitable for exploring any environment and operates in 3 modes. In the first, a human controls the robot's direction of travel, and the machine autonomously dodges the obstacles. In the second mode, the human sets the goal which the robot should reach. In the third, the robot simply drives itself wherever it wants to go and explores the entire space, making a detailed map of the area. Boston Dynamics founder Mike Reibert, who now heads the Boston Dynamics Artificial Intelligence Institute, shared his work plans, research results, and his views on the future of robots with EEE Spectrum. For example, he revealed that the Institute's first few Hyundai-funded projects will focus on making robots useful outside the lab by teaching them to better understand the world around them. Reibert showed concepts of such robots at the ICRA 2023 Robot Expedition, a review of which you can see at the link in the bottom. The AI Institute wants to teach these machines to watch humans perform tasks, understand what they see, and then do it themselves. At the same time, the robots need to know when they don't understand something and how to ask questions to fill in those gaps. Another of Reibert's goals is to teach robots to inspect equipment to see if something is working, and if it's not, determine what's wrong with it and make repairs. The Boston Dynamics founder hopes to see such robots as early as 2028 or 2029. In the meantime, the company's other robots are benefiting people. For example, Ontario Power Generation is testing Boston Dynamics Spot robot with a built-in arm for remotely tripping high-voltage circuit breakers. To gauge the robot's usefulness on such a job, several statistics are cited. In the US, for example, there are about 30,000 arc faults each year, and in North America, there's 1 or 2 fatalities every day. To save workers' lives, the company stocked 5 robots, and Boston Dynamics engineers developed an app for Spot, fully automating procedure. Spot can perform the entire operation autonomously, while a human remotely issues high-level commands. Organizers of the Neural Information Processing Systems Conference have announced the opening of the MEO Challenge 23 competition. As part of the competition, engineering teams will have to try to create ideal movement and manipulation controllers for humanoid robots by combining realistic models of the human locomotor system with artificial intelligence. The goal, of course, is to create robots with human-like dexterity. Organizers hope that advances in neuromechanical modeling and data-driven techniques will help bridge the current gap between expected and actual robot abilities. This year's competition will feature 2 tracks, manipulation and locomotion, and we'll keep an eye on the results. As always, we'll keep you updated with any breakthroughs in robotics. DJI has unveiled its new Air 3 drone, which has a transmission range of 20 kilometers and a flight time of 46 minutes. The drone is equipped with 2 1 1/3 inch cameras, a 24mm wide-angle camera, and a 70mm medium telephoto camera. Both are capable of capturing 48-megapixel stills, video at up to 4K 100 frames per second, and recording at 10-bit D-Log-M format for increased post-processing flexibility. Also among the advantages is omnidirectional obstacle detection. And Chinese company Chasing Innovation has announced a new consumer underwater drone for fishermen. The F1 Pro is controlled from a smartphone from a distance of up to 30 meters while moving on the surface of the water. 4 motors are responsible for omnidirectionality, and the battery provides for up to 6 hours of operation. If the F1 Pro goes out of Wi-Fi range, it'll automatically return to the GPS coordinates of the launch location. To directly search for fish in murky waters, the drone is equipped with an electric cable reel and 360-degree waterproof camera. The camera can be lowered to a depth of up to 20 meters, and infrared illumination allows you to see anything that's down there. The image with the depth data is displayed on the smartphone screen. And if the fish gets scared of the camera and swims away, you can at least snap a picture of him. Students at the ETH Zurich Research Institute in Switzerland have unveiled a new robot for inspecting tall metal structures. Magneco is something between a gecko and a spider, and it can crawl on vertical walls. To do this, the robot uses special modules with permanent magnets. Each of them, in turn, consists of several smaller magnets, which can be repeatedly magnetized and demagnetized in a fraction of a second with a short electrical pulse. At the same time, the magnets don't require electricity to remain in a given state, as current is only needed for switching. To make sure the robot doesn't fall, each of its feet can support 2.5 times the total weight of the Magneco, giving it the ability to walk even on the ceiling. In the future, the inspection robot will learn to autonomously avoid obstacles and plan its own route. Remember the first fatal drone accident? It was when an Uber SUV with a Test Zero pilot behind the wheel hit a woman on a bicycle on the road. The debate about who was at fault, the pilot, the autopilot, or a company, went on until recently, and now the verdict is in. Rafaela Vasquez, a test driver in an unmanned Volvo, was found at fault for the accident. According to the police version, the woman was watching the show The Voice while the car was moving and didn't notice the pedestrian. Uber's system recognized the man 5 seconds before the accident, but didn't determine exactly where he was going, so it failed to react. According to the verdict, Vasquez will not go to jail, but will spend about 3 years of probation under police supervision. The Surface Avatar project team announced successful tests of remote control robots from Earth orbit. A group of bots worked in semi-autonomous mode in an artificial Martian landscape, recreated in the German Space Operations Center. At the same time, NASA astronauts from the ISS corrected their actions as necessary. The robot's task was to carry out preparatory work for before the astronauts arrived on the surface of the Moon or Mars. The working group included Roland Justin, a humanoid robot that unloaded the landing module and installed the seismic sensor, Interact Rover, a mobile robot for terrain observation, and Llama, a robotic manipulator for scientific research. Everything the robots did was displayed in first-person view of the controller. The astronaut watched the machines and, if necessary, could press a button to switch them into avatar mode or fully autonomous mode. Control was carried out using an interactive joystick with feedback. The team accomplished all the tasks of the experiment in 2 hours. Also, the Institute of Robotics and Mechatronics at the German Aerospace Center showed its latest advances in robotic manipulation. Engineers are using deep learning techniques to teach the robot to grasp any object based on data from a single depth camera. In doing so, the robot tries to predict the final shape of the object. The approach is fairly successful, but work is still being done on more robust grasping predictions. A brain implant, artificial intelligence, and electrical stimulation have returned mobility and sensitivity to a paralyzed man. In order to actually perform the miracle, a team of researchers, engineers, and surgeons mapped the brain of patient Keith Thomas using magnetic resonance imaging. In this way, they identified the areas responsible for the movements of his hand and the sensation of touching it. He then underwent a 15-hour open brain surgery to implant 5 small devices. The system allows them to decode brain signals and translate thoughts into action using smart algorithms. Additionally, the brain and spinal cord were stimulated with electrical signals to restore movement and sensation in the paralyzed arm. In practice, it works like this. When Thomas wants to squeeze his hand, his brain sends signals that are decoded by the computer. The latter then sends a command to the flexible, non-invasive electrodes placed over the spine and forearm muscles that make the arm move. But wait, there's more! Sensors on the fingertips and palms send information about touch and pressure to the back of Thomas's brain, which registers the information as a sensation. Subscribe to our channel, join us on Telegram by the QR code on the screen, give the video a like, and don't miss new releases from the world of high technology.